Again, welcome everyone to the streaming telemetry session. I will introduce our today's speaker, Alexander Gorbachev. He is a NetAcad student, a NetAcad instructor, a NetAcad instructor trainer, a veteran of the Networking Academy program, WorldSkills winner, WorldSkills expert, and he will tell a little bit more about himself in his part. Alexander, the ball is now yours. You can take it and start sharing your screen.
Thank you so much for this warm introduction. All right. Okay, so can you see the slides now?
Yes.
All right, perfect. So hi everyone and welcome again. So today we'll discuss the modern approach for the network monitoring using the Yang data models, which is known as streaming telemetry, and how this is different from the classical network monitoring solutions. So I will briefly reintroduce myself again. So my name is Alexander Gorbachev. I am from city which is called Tyumen. This is in western part of Siberia. So as Eugene just mentioned, I started my journey with the Cisco Networking Academy about 10 years ago as a student. And since then, I got some professional experience in IT integration, IT outsourcing, and now I'm running my sort of own IT consulting company. So during today's session, we will discuss the reasons why network monitoring approach is changing today. Then we will briefly discuss some of the tools that we can use to experiment with these sort of new technologies. And finally, we will we'll take a look at some network simulation scenario where we can try it out and practice a little bit. So if you didn't attend the yesterday's session, I will briefly recap some of the key concepts to keep the general context clear, okay? So here we have some of the key characteristics of the so-called classical infrastructure, which is usually provisioned in sort of sequential and manual way. And when we talk about the monitoring of such infrastructure, we usually think of collection of different technologies, which are often not really compatible with each other, or at least you cannot combine them in some sort of programmatic tool chain. So such monitoring stack at some point becomes really forensic research tool, which doesn't really scale well because it lacks of consistent and standard data models for reporting. So why is that? So I'm sure that you're familiar with the tools which are often used today to have at least some sort of network visibility. So, but why it's hard to operationalize network monitoring using these classical tools? Shortly, because all these tools are either slow, incomplete, or very network specific. We know that, for example, SNMP uses something called management information base, which is vendor specific, and by default, it uses the periodic polling mechanism to poll every single object ID, which are in turn are not really self-explanatory, as you can see on the slide. So syslog is very basic mechanism, which is good for journaling in case of some disaster recovery scenario. But it's rare case when syslog collectors have built-in features for event correlation, simply because syslog is still very vendor specific. So in the end, we still have to use the CLI to go and check what went wrong with our network, right? So it's important to understand that CLIs are designed for the humans, right? And machines need something which we call APIs. So speaking of infrastructure that we want, we probably should think of some modern approaches and tools to enable our infrastructure to be not only reactive, but proactive as well. So to achieve this, we need some modern analytic tools where we have a single point for data feed and new protocols and standards for the streaming telemetry. So here is a nice representation of these concepts, which illustrates programmability life cycle of network infrastructure. And here, I want to point on the day 1 and day 2, where something which is called models used for both configuration programmability and for telemetry monitoring. So how streaming telemetry is different from monitoring which using the classical tools? So instead of pulling data from the network devices, the telemetry collector subscribes to streaming data, which is pushed from the data source, the device, in the network. And you can filter this telemetry data right on the device, which gives a way better network performance. So next, telemetry data is described using a structured data modeling language, which is called YANG. And because this data is well standardized and structured, it can be used for analytics across different and very, even very complicated tool chains. At least, so yeah, last but not least, since this data is encoded using well-known formats like JSON or maybe XML, it becomes compatible with the modern automation solutions. So let's take a brief look on what YANG is. So this is abstract data modeling language, and it can be used to model either device configuration or device state data. So in both cases, we can have open models which are defined for example, by Internet Engineering Task Force, which is known as IETF, and can be applied to any device of any vendor. So because, for example, any network device has some standard parameters for interfaces, right? So it should not be a vendor-specific library. And also we can have some vendor-specific models for vendor-specific features on the devices. So such data models explicitly and precisely define the data structure, syntax, and semantics. And after all, these models can then be manipulated by protocols like NetConf, RESTConf, or gRPC. So here is an example of such abstract open data model, which is called IETF interfaces. So in each module, we can have a number of containers which can be nested. And inside these containers, we have something called leafs. So we also see that some leafs have a read-write flag. So clearly because we can configure these parameters on a device. And some of the leafs are read-only, which are usually used to describe some operational state of some feature on a device. So in this case, the interface. Overall, we can see that it's very self-explanatory, including namings and data types. But again, so this is an abstract model. In order to use this model, we have to use something, some encoding mechanisms and some transport. So here is a brief overview on protocols, encodings, and transports, which are used to manipulate the YANG models. So currently, we have NetConf, RESTConf, and gRPC. And currently, the most efficient protocol for streaming telemetry is gRPC, which stands for Google Remote Procedure Calls. And it uses some very compact encoding called Google Proto Buffers. So long story short, this is just a simple key value pairs, okay? So nothing complex. All right, so this is the part of the theory. And again, a little recap from yesterday's session about very rich agility tool chest, which we can use for different network programmability scenarios. And just to mention, so this notion of network programmability tool chest is invented by Hank Preston, who's hosting a NetDevOps Live network programmability webinar series. So if you want to know more about the tools, so I will left the link in the end of the presentation. So you can see that the list of tools is pretty long, and this is not exhaustive, right? So probably every day we have any new tools in any new category. So, and today we will focus on something which is called TIC stack, and specifically on its part, which is called InfluxDB. And to simulate the interaction between Cisco devices and InfluxDB using the Yang models, we will again use the Cisco modeling labs. So if you missed yesterday's session, here is a brief overview of the CML2. And just to clarify a couple of questions that we had yesterday, Cisco Modeling Labs is a commercial product, and currently it's not available for academies for free unless you use it in DevNet Sandbox, where you can reserve a CML lab up to 4 hours. So on the slide, you can see some reference platform selected in bold. These are the platforms which have support for Yang models and streaming telemetry. So the old versions of the iOS and ASA, they don't support the Yang models, and respectively the streaming telemetry as well. So next, let's take a look at the TIC stack, which contains a number of building blocks, as we can see on the slide. So InfluxDB is a time series database built from the ground to handle and write high write and query loads. So InfluxDB is a custom high performance data store, so which is written specifically for timestamp data. So on the left, we have a Telegraf, which is the plugin driven server agent for collecting and reporting metrics. So Telegraf plugins have a variety of sources, and so it sources the metrics directly from the system and pulling the metrics from the third-party APIs. It also has some output plugins to send metrics to a variety of databases, services, and message queues. So it's not only the InfluxDB, so it can be something like Graphite, Open, TSDB, Datadog, MQTT, and many others. So it's not vendor locked. So at the bottom, we have a capacitor, which is native data processing engine. It can process the both stream and batch data from InfluxDB. So capacitor let you plug in your own custom logic or some user-defined functions to process alerts with some dynamic thresholds, or maybe match metrics from patterns or compute statistical anomalies and perform some specific action based on these alerts. So sort of like, for example, for dynamic load rebalancing or something. So on the top, we have Chronograph, which is the administrative user interface and visualization engine of the stack. So it makes really easy to set up and maintain the monitoring and alerting for your infrastructure. And it's simple to use and includes some templates and libraries to allow you to rapidly build the dashboards with some real-time visualizations of your data and to, like, for example, easily create the alerting and automation rules. So this is the brief overview. You can see that this ecosystem can be very smart and very complex if you want so. But just please don't be scared. It can be super small and easy to use when you want to just like kickstart your migration from the classical monitoring tools. So for this reason, just to kickstart the migration for the classical monitoring tools, today we will specifically focus only on InfluxDB and Telegraf plugin for Cisco model-driven telemetry to see how easy to set it up. Okay. So we will use the same infrastructure scenario as we left it yesterday. So here I want to point out that we will have a virtual machine with InfluxDB and Telegraf sitting in some real internet. and the CML is sitting in my office infrastructure behind the network address translation. So because we use pushing model, we will have no problems to stream the telemetry to the Telegraf collector, which is sitting in the real internet. So it doesn't work vice versa, for example, with SNMP, right? So because you have to have some sort of reachability to make a periodic polling from the SNMP server, right? So just a brief overview of steps that we will go through during the demo. So we will create a virtual machine and install InfluxDB with the Telegraf. So again, these components not necessarily have to be on the same machine, but we make it just for simplicity. Next, we will go through some basic configuration steps to configure the Telegraf collector. And after, we will make some simple configuration on a Cisco devices to monitor the CPU utilization and some interface statistics. And in the end, we will create a couple of dashboards and probably we will enjoy them. I hope so. All right, so it was some really brief introduction to the streaming telemetry as a concept. So let's jump to the demo. So first and foremost, we will go and create the virtual machine to host the InfluxDB instance. So here you can see the Cisco Modeling Labs infrastructure, which is up and running, busy waiting for us. So we will come back to it later. So for the virtual machine, we're going to use the AWS cloud. So just for simplicity to do next finish to create the virtual machine. So we will use the CentOS based AWS Linux. So yeah, relatively small instance. Next. Yeah, so here we have to add some tags here because since we are using the AWS as a production infrastructure, we have to tag the virtual machines in order somebody or something automation tools did not just accidentally delete the virtual machine. So project influx and environment test. Right. So here we have some security groups configuration, which we have to apply in order to permit some of the ports for the virtual machine to access from my on-premises environment. So the InfluxDB running on the TCP port 8086, so we have to permit that. And the Telegraf is working on the TCP 5730. So we also want to enable the SSH. And we are going to launch our virtual machine. So this is the just the warning that I have the key pair using for SSH. Yes, I do. And we're going to launch our virtual machine. So we will wait for a couple of seconds to come up. Let's name it Influx. So as you can see, it's still pending. All right, so now we are able to connect. So here's the very convenient shortcut that we can use to SSH to the virtual machine. So let's go to the terminal. The copy doesn't work for some reason on my Ubuntu machine. All right. So, okay, in order to install the InfluxDB and Telegraf, so we have to go to the influxdata.com portal to the downloads, and here we have some convenient shortcuts for any building block of the TIG stack. So we're going to use the latest version of the InfluxDB. And here you can see a variety of options, right? You can have a Docker image, distributions for macOS, Ubuntu-based images. So we are interested in CentOS-based images. Okay, so we get these RPM, and we go to install it. Yes, we do. All right. So next we have a Telegraf to install. So we're doing the same procedure here for CentOS based distribution. Yep. All right. So we have the InfluxDB and Telegraf installed. So next, what we should do, we can check the service of the InfluxDB. So this is the system CTL status, system CTL status, InfluxDB. So we can see the service is dead. So we want to start it, right? Start InfluxDB. All right, so now it's alive, and we can go and we can check whether it's working. So we'll take the public IP address of our virtual machine and just go to the port 8086. And yep, so we have InfluxDB up and running. So just a couple of single initial configuration steps. So we have to provide the username, the password. So the name of the organization, and name for our first bucket. So for the data which will be used for the telemetry. So let's call it demo bucket. All right, we're all set. So next, what we want to do is to generate some configuration for the Telegraf. So again, this is a separate building blocks. You can have Telegraf installed in a different virtual machine in a different infrastructure. So you have to configure your Telegraf apart from the configuration of the InfluxDB. So we can go so first that we need to do, we have to create some token in order to Telegraf can be authorized to write the telemetry data. So we go to the data on the left. So we see the tokens, and we need to generate the read-write token. So let's call it demo. And we have to grant the read permissions and write permissions on our demo bucket. Okay, we successfully created the token. We will come back to it a bit later. So now we have to configure the Telegraf. So the most convenient way to do so is to go to the Telegraf tab in the data tab on the left, and we have some convenient tool, InfluxDB output plugin. And here we have the Telegraf configuration generated for us by InfluxDB. So we can see it's automatically put the public IP address and port in our configuration. So here we have insert our token or use the environment variable. So organization and demo bucket. So super simple. Okay, we're gonna copy that, and we go to back to the terminal. So now we have to edit the configuration of the Telegraf, which is sitting in etc Telegraf colon. right? So the config is pretty long. So we don't need really to focus on the default parameters. The only thing that we have to do, since we are using the InfluxDB version 2, we need to comment this statement for output plugin for InfluxDB version 1, right? Okay, so, and we just move to the end of the file and we'll just paste the configuration which is generated in InfluxDB for us. And now we go back to the token and we will simply copy this token and insert it right here. All right, so now our Telegraf can connect to the InfluxDB instance, which is sitting on the same host. So next, we have to configure the input plugin. So since we are using the Cisco devices, we need an input plugin for the Telegraf for the Cisco model-driven telemetry. So here we have the documentation portal of the Influx data. I will leave the link in the end of the presentation. And so here we have a documentation for the Telegraf. So if we can go here and search for the plugins, we can simply find the what we need. So we have the options for Cisco GNMI telemetry, but what we are looking for is Cisco model-driven telemetry plugin. So we can actually just click on the view button and we will go to the GitHub repo for this plugin. And here we have a super convenient configuration that we can use by default. So, and we will do exactly this. So we have to insert it in our Telegraf configuration. So as you can see, it's just a couple of parameters. So we will use gRPC as a transport, and Telegraf will listen on port 5730. So, and this is just the some alias for convenience. So we can left it as is. So we're going to save this. So next we have to start and run our Telegraf service. So we will check it. Systemctl status Telegraf service. So currently it's dead. So what we want to do is to enable it and start it. Okay, we can check the status once again. And yeah, so we have a success. We can see that the inputs that we pasted in the configuration is okay. And the output plugin is also okay. So meaning that the Telegraf can successfully authorize in the InfluxDB instance. All right. So what do we do next? So next we actually go into the our Cisco devices, to our infrastructure. So for example, we will take these two routers. And first thing that we need to do is to enable Yang services. So yeah, let's actually take a look first. So we can check the status of the Yang management process services by issuing the command show platform software Yang management process. So we can see that it's not running at the moment, most of them. So we can go to the config mode and enable it using netconf Yang. So it will take a couple of seconds to come up. So let's do the same on the second router. Netconf Yang. Right. So we will check it once again. Now we can see that all processes are in running state. So now we can actually try to configure some telemetry subscriptions. So let's go to the configuration mode and issue the commands telemetry IETF subscription 1. Okay, let me make it a little bit wider. So which options we do have here? So we have options for encoding. We have some filter options. We can configure the receiver options such as IP address and the port, source address, some policies related to the update, and some streaming options. So for encoding, we will use GBP, which stands for Google Proto Buffers, as we discussed earlier. So this is the encode KV-GBP. Okay. So for the source address, we will use the internet-facing address of our devices. So let me check. Right, this one. Source address. Okay. So we also have to configure the receiver. Receiver IP. So let's go back and copy it once again. Sorry. Yeah, I believe this is the word. I missed the word address. Yeah, IP address. Our public IP address. So next we go with the receiver port. So remember, we are streaming to the Telegraf collector. So this will be the port 5730. Is it 3? Yeah. Okay. And as a protocol, we are going to use gRPC over the TCP. gRPC TCP. So for update policy, okay, so let's first configure the filter. So there is a couple of instruments that allows you to go through the all models. So I mean Yang models, because we have a lot of them for different platforms. So in this case, we are using iOS XE, and you can see there is the GitHub repo for the whole models related to the Cisco devices, which are NXOS, iOS XE, and iOS XR. So you can search this repository. So here we have a lot of different versions, and inside each version, you can find a ton of the models, right? So a lot of them. So I will left the link for this GitHub repo as well in the end of the presentation. So I have some filter XPath prepared, as you may guess. So as a filter, we will use the XPath and this path. So let's take a look on this. So here is the process CPU iOS XE Oper, which means operational data. We're using module CPU usage, and we're looking specifically for CPU utilization. And inside this CPU utilization, we have the leaf, which give us an option to check the utilization each 5 seconds. So let's apply this. For the update policy, we have a couple of them. We have on change policy, meaning if you want to track some interfaces going up and down, you can configure the on change policy. So in this case, we will use the periodic policy, and let's say, yeah, it looks like a sort of complex calculation, the unit in units of hundredths of a second. So for example, let's use the 500. So, okay. And we finally need to configure the stream options. So we have a couple of them. We have a native, we have notifications native, and we have the push. So we will use the Yank push model here. And let's take a brief look on our configuration that we have right now. So again, this is the first subscription. We're using the key value pairs of Google proto buffers. We're using the Yang XPath filter for the CPU utilization each 5 seconds. We're using source IP address from facing our internet provider. We're using the Yang push stream mechanics, and our update policy is 500 tenths units of a second, whatever this calculation means. And we have configured the receiver IP address, port, and the protocol for the transport. All right, so let's copy this configuration over to the second router. The only thing that we have to change is the source IP address. All right. Source address. Okay, just to double check. All right. So let's configure another configuration. And this time we will use the telemetry for the interface statistics. So we can use almost the same chunk of the configuration, except this will be subscription number 2. And we'll just simply copy and paste it as this. But for the filter, we will use a different filter, which is used for the interface statistics. So just to remind, we are running DMVPN across all these 5 nodes. So let's go and do the monitoring of the tunnel interface, which were used for the DMVPN. Again, so the path is really self-explanatory, right? So we're using the interfaces iOS XE operational Yang model. So, and next we going to interfaces. So yeah, so this is the state for the list of interfaces, and specifically we look for the interface which is named tunnel 100, and we would like to receive some statistics from this interface. Okay. All right, so now we have 2 subscriptions. I will take the second one and copy it over to the second router. And again, we have to change the source IP address here. All right, so we actually have the command to double check whether we configure the all parameters collectively and whether it's working or not. So we can do show telemetry IETF subscription, and here we have options. So we want to see all and with details. Okay, so here we can see the subscription ID 1. So it's configured, it's valid. Here we see the stream method, which is the Yang push. So we have the XPath filter for the CPU utilization in 5 seconds. We have a periodic update policy, our encoding, and our source address. And here we have our receiver configured. The same for subscription ID 2, right? Configured, valid. and the rest of the parameters are the same. All right, let's double check here. Yep, so it's valid, and the second one valid as well. All right, so we will come back to it to this topology in a couple of minutes. So now we go back to the our InfluxDB, and let's create a couple of dashboards. So we will name the dashboard as CPU, for example, and let's add a cell. So okay, this is gonna be for the very first router, and here you can see that we have our demo bucket, and in this bucket we already have some telemetry from our infrastructure routers. So this, so let's take the CPU utilization telemetry first. So as we can see, this is the leaf, right? The 5 seconds that we configured on the router. So this is the Telegraf host name, and here we go we continue to follow the path, and we take the source of this CPU utilization for the very first router. So we're good with this. We also have some parameters when we want to update these metrics. So for example, we will update it in 5 seconds. And so this is the pretty standard graphic, right? So we also have options. Like for example, for CPU utilization, I really like to use the gauge because it's really, really nice. So we would like to use the less values in the CPU utilization. And for this, we will leave it as is, okay? And we also want to add the second cell for the second router as well, using exactly the same methods. So we will change it to the gauge as well. All right, we're all set. And we can also add a cumulative cell, so where we probably want to monitor the both characteristics of both routers, right? So it depends on you, right? Okay, so yeah, let's rename this cell for the second router. All right. Let's also create a dashboard for interfaces monitoring. So we're going exactly the same procedure. But now we are going to our interfaces telemetry. So you can see that it's a lot of parameters since we took the whole statistics of the interface. So let's focus only on the RX and TX parameters. So here we have only the tunnel 100, right? So we are taking the first router, right? So this is a subscription number. We not necessarily should check it. And for example, the TX as well. All right. So you can actually customize the graphics using some custom values if you want. So let's name it traffic. So, and we have traffic in kilobits per second, for example. So pretty much of the opportunities that you can customize, you see. So it's a really nice and convenient tool to use. All right, so let's add the second router as well. Interfaces, RX, right here, channel 100, and router 2. And also we will add the TX. Okay. And we also would like to customize the labels. All right. So we are all set. Okay, so we have some graphics and we have some dashboards. So let's stress test the infrastructure. So for example, if we want to see how these dashboards reacting to the some events in our infrastructure. Okay, so this is the periodic updates in 5 seconds. We can see that it's not so much traffic here, and the CPU usage is pretty small. So what we would like to do, we would like to issue the debug all command to just kill the router CPU. And the same here. Yes, we would like to kill the router. So as you can see, it reacts super quickly. So even we have the really massive debug output, so it has some resources to still stream the telemetry. So let's actually test the second dashboard. So we can actually ping the internal network behind these two routers over the DMVPN just to check the telemetry on the interfaces statistics. So here I have some command, which is the ping of a pretty big size, and we would like to repeat it 1,000 times. And this is what we would like to do on each router. Yeah, so we have the connectivity, meaning we have some traffic. Let's do the same on the second and third one. All right. Well, so the probably CPU experiencing some big issues, right? Well, okay, let's stop it for a second. Yeah, we have some connectivity, but yeah, so the CPU is doing pretty bad. All right, so let's take a look on the, yeah, so we can see that some of the traffic increased on our on-premises routers. So, and this is basically it. You can add as much data as you want, so you can customize your dashboards as you want. So we didn't touch the other building blocks because they are really complex. So if you want to see some machine learning and anomaly detection, so clearly you can use these data to to teach your network to react to the events and be at some point proactive. So, for example, if we have the some machine learning mechanisms and we see that we have some, for example, traffic decreasing, and it can be integrated in these CPU checks, for example. So this is pretty much of the demo, and just let me put some closing slides. So I put it the link for the influx data documentation. So one of the really good tools which is developed in Cisco, this is called Cisco Yang Suite. So this is basically a container which you can use to explore the different Yang models of the different operating systems, and even add your devices to this instrument, and even try to issue some netconf or restconf command using these Yang models. So here's also the link for the free CML if you would like to play with it in DevNet Learning Labs sandbox, and link for the great channel that I mentioned, which is Net DevOps Live, hosted by Hank Preston, if you would like to know more about the models, the network programmability in general. So this is pretty much it. Thank you so much for your attention. Any feedbacks very appreciated, and I think this is the time for the Q&A if we have some questions.
Alexander, I think we do have, well, we don't have a lot of questions. However, we do have a couple of. I'm assigning you the question from Will. Just appeared a couple of minutes ago. How is the impact in the amount of monitoring traffic?
I think the question is how, so is it bad for the network performance? So the answer is no. So because, for example, if you compare it with the SNMP, so if we use default SNMP server, so by default, you don't filter any SNMP object IDs. So SNMP server, if it has some automatic discovery mechanisms, it will pull the whole management information base from the device. So meaning there's a lot of object IDs, and this is bad for the network performance. When we use the streaming telemetry using the Yang models, so first of all, we can filter which data we want to send to the collector. And the second one, the encoding of this telemetry data is super small. So this is the simple key value pairs. So it doesn't really impact the network performance.
Thank you very much. I want to mention for participants that we just opened the polling. It will be active for 9.5 minutes more, so please make sure you take the poll. That's important for us. You have a couple of minutes to leave your additional feedback. We do read it, honestly. So don't hesitate to put something there also. Especially if you want to communicate something back to us or maybe wish something for future sessions. Alexander, there is another question also. I have assigned it to you. Can you scale the data logarithmically or perform transformations, I believe, of the data, for example, graph outbound and as negative?
I'm not sure that I understood the question correctly, but so from what I understood, I think it's pretty much scalable model. So at least the if we talk about the tick stack itself, so let me return back to the to this picture. So as you can see, the InfluxDB can be clustered. The capacitor, which is the real-time streaming data processing engine, which takes a lot of load when we use some machine learning, and any other alerting frameworks, and anomaly detection. So it can be scaled as well. So you can, for example, put so if you have a super big infrastructure, you can put the like 100 of instances of InfluxDB and capacitor. So you can actually scale the Telegraf as well. So you can have a multiple Telegraf collectors streaming data to the InfluxDB cluster and capacitor cluster. So the short answer is yes. So I hope I understood the question correctly.
Thank you, Alex. Just one more from Luis. If you can look at it, is this managing and monitoring solution is adequate for things or resource constrained devices?
Absolutely, yes. So because the encoding is super compact, it doesn't really require a lot of processing power to send the telemetry. So I don't have the example of the how it's looking, but if you can Google Google protocol buffers, right? So you will see that this is super small key value pairs. So the IoT devices doesn't expect to be powerful to stream this kind of data. So, and of course the IoT devices, they don't stream it like super periodically, right? So it depends on the use case, but generally they send telemetry not so often, like we would like to see from the devices who have some big compute power.
We are at the top of the hour. I will take the last question within the recording. Then after that, I will stop it and we can speak a little bit more. Could you please, Alex, recommend the best documentation or tutorials for InfluxDB?
So the best documentation for InfluxDB, this is the Influx data documentation site, which is used. So docs.influxdata.com. So here you will find everything that you want to kickstart your migration from the classical instruments to the new generation of the modern telemetry infrastructure.
Alexander, thank you very much for taking some additional questions. It was a very great presentation. I personally was quite impressed with it. So would stop the recording. Thank you very much. Thanks everyone for participation and join us for next sessions.